Hello, protocols, packets, and programs. I am addicted to the repetitive dying and retrying of roguelike games. Modern ones have fun mechanics like Balatro or beautiful designs like Hades. But I've also played the old school ones, the ones that cared nothing about user frustration, being absurdly difficult, or offering scarce rewards. The ones like Angband, NetHack, and fixing CVEs. Which means this week we catch up with Kalyani, analyze some AI arguments, and discuss the latest AppSec news. Create a character and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Think your terminal emulation is secure? Think again. Passwords and firewalls alone won't protect you. Cyber threats are evolving, and so should your security. Rocket Secure Host Access gives you phishing-resistant, password-free protection with leading-edge encryption. Your mission-critical systems deserve more than good enough. Secure your green screen access and stay ahead of the threat. Rocket Secure Host Access. The future of TE is now. Learn more at securityweekly.com/rocket software. This is episode 333, Son of the Beast, recorded June 2nd, 2025. I'm your host, Mike Shima, and I'm here with Kalyani Pawar. Hey, Kalyani, throw some horns. Celebrate the good number.
Hey everyone, it's a nice number. I like this number. It's I don't know if this is the affirmation number or not, but I keep hearing about those repeatable digits.
I guess, and it's also sneakily a palindrome, one of the easier ones. So we'll have Math Nerd Weekly coming up sometime over the summer. Let's see let us know how many math nerds are out there, because speaking of doing math, that's one of the things that LLMs don't seem to be very good at. Not even just solving 2 + 2 or the simple things, but apparently people are still using LLMs for lots of coding. And Kalyani, I wanted your help to talk through some prompt injection examples, but then maybe talk a little bit more generally about our attitudes towards AI. So, got a pair of articles. The first one is a remote prompt injection in GitLab Duo leads to source code theft, and this comes out of Legit Security. So, some really good write up by Omer Meiraz, and the title helpfully kind of gives everything away. And what was interesting about this is that it, once again, interesting to me, it shows the mix of code and data, meaning prompts show up everywhere, because the researchers ask themselves, could we embed hidden instructions, in other words, a prompt, in pretty much any part of a GitLab project and influence the behavior? And they showed that you could put a prompt that would be interpreted by the LLM into a merge request, into commit messages, to descriptions, other comments, and of course the source code itself. So it's one of those things that you don't just have insert prompt here for your system. It's insert prompts anywhere, everywhere. And I don't know, on the one hand, that seems good, but on the other hand, that seems kind of tough. How does that strike you, Kalyani?
I'm not just gonna say tough. It sounds a little scary.
Yeah, okay. Fair point.
That something can be hijacked by just like a commit message. And so it makes me think what other workflows are there that are currently poisoned. And I think if we take a step back and we use our AppSec minds and try to threat model a similar scenario, I mean this exact scenario, sanitizing prompts is just not enough right now. I think we are going back to our fundamentals of trust and boundary, right? Like, what is the trust boundary here? And are we supposed to trust just an input stream that is sent our way? I think we're back to our AppSec fundamentals, even on a new interesting attack surface. I feel like if your tool cannot attribute where a certain suggestion is coming from, it's just like like maybe don't just like trust it. It's like, playing telephone with an unknown
Yes.
caller or something at this time. I watch way too many horror movies, I guess.
But you're right about that because the call is coming from upstairs or the killer is inside the house. That's what the story of what prompt injection is, because as you pointed out, nobody's saying this is where this is the place where we can expect the prompts to come from. And even in this write up, it was really interesting because it also touched on one of my fun topics, parsing, because they're rendering Markdown into HTML, which the GitLab, and that's not an unknown type of threat model. But what was interesting is that it would render it and then update what it's rendering based on the prompt. So the prompt could just be updating itself, and you get essentially either a race condition or you're doing that separation of boundaries, exactly like you said, where you're saying, we already had our normalization at this point A, but the prompt is now updating the markdown, updating the HTML at point B, and we're just assuming that security's already been done, but it hasn't. And this to me is, I think, maybe just I don't want to go into rantiness, but it feels like just an absolute regression in app design and secure design, which I will also say, maybe acknowledge that it's extra hard because where do you expect a prompt to come from? Like, I think maybe that's what this really all boils down is where is that prompt coming from?
And how much do you trust it?
And how much do you trust it? And that, I think, is a great segue into another article. This from another AI-focused security folks called Invariant Labs, who had an article called GitHub MCP Exploited Accessing Private Repositories via MCP. And so MCP has been all the rage. And if you read the spec for MCP, they'll say it's like USB that connects everything together. But honestly, it feels just like a very old API that just happens to have maybe some authentication on top of it, and maybe some, call it what we used to would have called this XML. Now it's maybe just JSON or just some structured format for how to talk to each other. But it's nothing fancy. And in fact, it feels like a regression in secure design because you have what these researchers are calling a toxic flow, in the sense of a way for the MCP server to accept some prompts to say, here is an instruction that I should follow because I read some text somewhere within this user's account, and I'm going to use that text to put together a commit. It just so happens this commit has information, is being made into the public repo using information that's in the private repo because it's working within the context of the user who owns this account. And I think that's where that's a very obvious contrast or a very obvious problem of crossing trust boundaries there, going public and private. So I don't know if that's another thing. How would you, again, even just threat modeling this? It doesn't seem that difficult in practice, or in theory, but in practice it seems to be failing.
Okay, so just real quick for our AppSec friends who are still confused with what toxic flows is. Think about cross-site scripting is a toxic flow in your browser. It's just that in this case, we're dealing with AI agents, and unfortunately, we don't have a CSP to get out of this mess, right? When we think about our traditional SDLC models, we always talk about we always consider the threat of data leakage or trust leakage. It's just that here we don't know who exactly our AI agent is working for. I feel like for simplicity's sake, we should just consider context windows as if they are one untrusted shared space. Think about a Slack channel where malicious payloads can be pasted anytime, right? Would you trust anything that's coming from the Slack channel? No, right? So I feel like we've seen a similar flavor of problem time and again. And so it would be nicer if we could find ways in which we could have we can attribute like signed attributes to who pasted this piece of code. If it's like an important piece of code, it'd be nice to know who the co-authored, or even if it's an AI agent working with a human being, it'd be nicer to know who wrote that and who signed this. And so, like we have these important functions that get copy pasted throughout the code bases. Well, at least we know where it came from, rather than it just being like, yeah, the agent probably learned from it and then went on with it. I also feel like this introduces a new flavor of stride for us, because think about like prompt injection is something where spoofing and tampering just made a baby. That's how that's how I would like to think about it. And I think it's compartmentalization has become more important now than ever before. I feel like we do these things anyway within our environments. It's just that it's a new surface altogether.
Yeah, I
But yeah.
think Microsoft, I'm sure, appreciates you keeping Stride alive. Um, there's a thing I'd add to what you were describing too, because with Git you can have signed messages, and you can even force signed messages, so you know that this was Mike committed this, and or at least the GPG key associated with Mike committed this, and here's the one associated with Kalyani. But when you get into the AI agent acting on behalf of either of us, for example, do we really want both that agent to commit as me? I kind of would prefer not to. I'd rather have me as the human, showing my human changes, give the AI its changes. And the other problem too is, how or why do the AI make this change? And this is where that source of the cross-site scripting payload, the prompt injection, to riff on what you were describing, becomes tougher because, as I said at the beginning, it's everything. It's just a mix of code and data, and if Stride if Stride is becoming parents of yet new threats for AI, we've also forgotten the old ancient SQL injection technique countermeasure of just separate that code and data. We don't have a prepared statements for prompt injections, nor do we have output encoding for, if we consider this cross-site scripting, because prompt injections are very much, where is that context window? What are, it's just tokens that happen to look like human language. And it's very hard to say, this is the part that can be a prompt, this is the part that's not a prompt. So
Yeah.
I guess I don't know what I'm adding there, other than say this is going to be a long problem to solve. I don't know.
It's an architectural flaw. It's going to take quite some time. And it's not just a flaw in the GitHub MCPs server itself. It feels like a major architecture problem.
Yes, and that's where too we talked a little bit in the past about even just the authentication around MCPs, and do you act on how do you put OAuth on top of this, and with those OAuth grants, do you grant to the act on behalf of the user for a Mike, for example, or Kalyani, or do you just say this is even more restricted for the AI agent? And even before you get to those grants, what access does it have to the environment? Does it have access to the file system? If all you had was an MCP server that did some math, that's the equivalent of, why does this calculator app have access to the network from 10 years ago, of when Android and the Apple iOS app stores were getting started. So it feels like what is, the more things cliche, they stay cliched. I don't want to go down that route. But let me switch to another article real quick. Kalyani, one last one on AI, and then I promise, you mentioned secure architecture. We'll get into some secure design as well. This is from Pavel Samsonov, called "The AI Hangover Era," and it's part 3 in the Everything app series of posts that he's put together. What it really boils down to is not really an AppSec angle specifically, but more of, how are developers relying on LLMs? How are developers using it? And where is the value? And this is, I kind of wanted to highlight for, honestly, you and for our audience, because I'm still searching for the Janet Jackson approach of AppSec towards LLMs, in the sense of, what have you done for me lately? And if you're just making lots of work, you're making lots of work. It just so happens this is an AI rather than an API. But I haven't found the value from LLMs as applied to AppSec, in the sense of, it could be a fancy grep, but it's sort of still a grep. but I have not seen it be helpful from a threat modeling perspective, just on its own. Like it can ask some generic questions. I don't know. That's my experience in my lens. I don't know if you've seen something different, Kalyani, if AppSec or AI has been helpful for you on AppSec.
I resonate with the point you're making that we're hitting a wall where LLMs and Pressbit don't really help. Say, as an AppSec engineer, I don't think I care about writing a CRUD controller faster, but I care about finding like insecure patterns throughout the code base, right? And how I can do that faster. It's not just about writing the code, but what happens when the code touches prod. And that's what an AppSec engineer truly cares about, right? I think more, I think a layer on top of all this is that we should start asking like, we're asking the wrong questions. We're asking what can the tool do, but instead we should be asking what can the tool help us from stop doing? Like how can we avert threats, or something like that. Yeah, that's I share that sentiment with you where is it helping me anymore, but just rather creating noise over clarity.
Yeah, or is it just a fun thing? Because there's so many, I think there's a lot of maybe developers, maybe AppSec folks that are just hitting FOMO and being like, oh, I should be using this LLM because everybody else is. And the LLM did some equivalent of a bit fancier NPM init, but all it really did was some scaffolding, or it gave me a very generic algorithm, which, okay, maybe that saved me a little bit of time because I forgot how to do that in Python, for example. But in terms of value and like from a product perspective or saving me time, it's not so much just writing code that we focus on. It's sort of where's our risk or where is our design or architecture. So let's use that as our chance to get out of just having to talk about AI all the time and only, and talk a little bit about design. So follow along with me, if you will, Kalyani. There is another article from swift.org called How Swift's Server Support Powers Things Cloud. And sadly, I don't really have a good Swiftie reference here, a Taylor Swift joke. But good for her for finally getting her music back. I appreciate that. I'm looking forward to hearing more. But in this case, this was not so much about getting the masters of some great music back. This is actually changing the masters, if you will, if I could try to torture that particular metaphor, changing the masters of the source code, in the sense of the article, they describe how their legacy cloud server built on Python 2, Google App Engine, and it worked. But they also had to create a custom C-based service just out of pure performance. So now you have some Python 2, which Python 2 is a little bit on its way out. And C is not the favored language these days. And so they went through a rewrite. And so this is where I'm slightly sad that John can't join us today, because I love having that discussion of rewrite, refactor with him. And what the article goes into, they thought about, well, if we're going to rewrite this, could we go into Java? Hey, that is memory safe. Python 3, so maybe that's just a version bump in the language. It could be into Go, of course, and a little bit dangerous, C++. But they went into Swift. And the reason I'm harping on this is they very helpfully describe engineering decisions for why they wanted to rewrite their code. They saw some problems around latency. They saw some problems around maintenance. They saw some problems just with Python 2 and C being basically being legacy. These are going to be really hard to deal with. And I'm repeating myself a little bit on the maintainability aspect. But their choices didn't really focus on security, or security wasn't a driver, even though they benefited from security at the end, because with the better memory handling, the ARC handling of Swift, they saw not only lower latency, which is better user experience, which is great. They were able to get rid of that C code, so they just unified everything into Swift now, so one language that's more maintainable. And it's 30,000 lines of code, which honestly does not seem that huge. All things considered, especially compared to some of the mono repos that I've seen explode out there. So this was my way of saying, I like this article, just well written, and I like looking at articles to figure out, why did software developers, why did these engineers make these decisions in programming language or designs? And did they even think about security? Or did they even have to bother thinking about security? So I don't know. Am I just kind of am I a nerd about rewriting here, Kalyani? Or is there something here that also speaks to you in the sense of like, or you recognize when you've had conversations with developers?
I think we've had a little bit of this conversation before in one of our episodes from B-Sides, where we were talking about like what are the team's needs and what is the team's expertise, and then we go for building an application from that end. And I think that's a very interesting approach to obviously solve a big problem, as it took quite some time to do the rewrite, but also it was a strategic rewrite, not just like we woke up one day and we decided this language
We're
doesn't
just
work
going to
for
do
us.
this because we listened to ASW. Yeah, exactly.
Yeah. Um, and so I like how, it is a strategic way of dealing with technical debt, but also like it is giving added benefits of like improved performance, like 500 seconds, 500 requests per second. I think that's great performance. Reduced latency, and that's better security also. So um, I would rather say it is a more strategic way of dealing with technical debt, and also security debt at the end of the day is technical debt. So
Yes, fair point.
strategic way of dealing with it and then solving a problem. Yeah. And also I did read that they used it internally for 2 years before going live. And I think that's such a well thought out approach to problems with usability.
That's a wonderful point. And they had both, you touched on they could show in quantifiable numbers improvements. If you can come up to, some execs and say, we did this change, we rewrote some code, and we saw a threefold decrease in our compute costs, that's pretty awesome. Everyone loves to save money. And if as you pointed out, we did this carefully and strategically over a 2-year period to make sure we didn't upset our users, and we kept all of that data integrity over time. And I think this is where maybe we would get some AI proponents who would say, well, we could have had the LLM just rewrite some code or do an automatic translation from Python 2 to Python 3. But I think even if they did that, you still need maybe not 2 years, but you still need a strategy for how do you trust that code? How do you trust that you've maintained the integrity of user data, as well as the functionality of the old site is actually represented in the new site? So those are great points that I wanted to maybe just evangelize to our AppSec folks to appreciate that developers, maybe they don't say explicitly they care about security, but security is actually a byproduct of a lot of things that they do care about. So that's my let's all, that's my kumbaya moment of the day. You mentioned too, Kalyani, secure architecture or secure designs and even just threat modeling. I pulled another this was a bit more technical article about Tachyon, which is the nickname of an old exploit on iOS. It's a long article. I would say you don't have to necessarily dig into the technical aspects of the very beginning of the article. Skip down to parts 4 and 5, the aftermath, where the author is pointing out that iOS 14, where this old Tachyon exploit first appeared, roughly 5 years ago, the change from 14 to 15 to 16, 17 to 18. I sound like the count now on Sesame Street, but over those changes, what they saw in terms of reaction from Apple and hardening iOS was being strategic. And this is a callback to one of those things you had just said just a couple minutes ago, in the sense of Apple and iOS didn't just fix, oh, here's a bug that somebody found they found and they exploited. They did the same thing. They did the same approach for all the other potential bugs for pointers or all the potential bugs for heaps. They separated, kernel heaps such that this particular heap can only ever be used for kernel objects, and you can never do this kernel object type confusion method or technique of exploitation. And it's that idea of getting rid of techniques that I just absolutely love as a byproduct of their engineering approach, rather than we got a bug report, it affects potentially billions of people, let's fix it quickly, move on, get the next bug report, and go back to a little bit of that roguelike joking I was doing at the very beginning, where you just die and retry fixing particular CVEs rather than dealing with an architecture. So this one, once again, I had fun reading this because it's a well-written article, but I will admit I skipped some of the technical details up front to get into these really good takeaways about just don't address the instance or the example of the flaw. Try to address the underlying cause of the flaw. And apparently, with the from the hacker community perspective, iOS has been doing a pretty good job of that. So I don't know if again, tachyons. I don't know if you've even got a good sci-fi reference on tachyons there, or if we should just segue into something else. Let me take you into the world of AWS, Kalyani. So we've gone from AI to secure designs, and now I do want to talk about something more directed around AWS and flaws, because I'm leading up to one last article I wanted to get to. And in this case, you were talking about trust and identities when we're talking about LLMs. Like, who's making this change? Is it Mike? Is it Kalyani? Is it the AI? Is it crossing a trust boundary? Well, in AWS, there's actually lots of roots. And honestly, if pressed, I personally would have a very difficult game of trying to list all the ways that somebody could do the equivalent of root permissions within AWS, or administrator permissions, because once you get into the world of wildcards and splats and the overlapping provisions, or even just as this article calls out, is production really production? Is dev really dev? These are human labels that might not actually mean what they think they mean, to quote yet another movie cliche. But this is just one of those good reminders of there's a lot of simple stuff that AppSec needs to do. And this is more than just who gets root on your laptop, it's who gets root in your cloud. And so, Kalyani, you've worked with a lot of developers in the cloud environment. How easy is it for them, for you to say, check your root, and they can come back an hour later and say, oh, we did, we're fine? Does that ever happen?
I think this feels like one of the things which we're just used to living with. Is
You've
it what I
accepted the pain?
Yes, like it's just I feel it's like a crucial reminder right now for me, where it's just like, yeah, you should keep auditing access to your AWS accounts. And that's like one of the step one things that I recommend to every startup every time they talk about their security posture, where I'm like, yeah, you need to audit your access. Not everybody should have the ability to nuke production from the orbit, which seems like it seems like a basic thing to do in like really mature environments, but like in something that is really nascent, this feels like a necessary thing to mention. But you know what struck out to me from from this whole article, this whole conversation, was the neglected accounts, right?
Oh,
Been in so many situations where I've seen like this was just supposed to be like a test account, and then suddenly there's like important data sitting in that test account, and it's not its test account anymore, even if it has the name test on it,
yeah.
because now it's like it has like important production data sitting on it. And that's like they said, if you just go by labels, production just is production, sure, but also a test account could be production. And then think about the nightmare where an intern could just, I don't know, elevate their accesses, and they don't know what they're doing, but they end up nuking production. And I think it's everybody's nightmare at that point. But I also like how the article has touched on like these are like very basic security hygiene kind of things, like don't over provision roles, or have a basic understanding of what trust relationships look like. My favorite part, though, about this whole article was how visually pleasing the graphs are
Oh,
for someone who has a visually running brain all the time. Like I feel like I need to see evidences of things laid out, like a whole map. I definitely love that about this article, and I feel like AWS should definitely pick on it. Yeah.
Yeah, and I think I very much also appreciate just a good visualization, whether they're metrics or tell that story with one picture in 1,000 words or 10,000 words or what have you. And this, what was neat about this too, it showed a couple different ways to visualize, even getting into some really fancy markdown as well in Mermaid files. So there's ways of basically showing the complexity of all these interrelationships. And I think the graphs can help convey this is a problem. We should deal with it. And then you start to get into strategies of what does our access model, what should it look like? What are the roles we should get rid of? How did we get tripped up on all the places where assume roles are being used and we didn't realize that there is some privileged escalation happening just out of old legacy code, or the ways that the 2-year-old version of this service or microservice was written up, and things change over time, especially for startups as they grow and become more complex. Part of this too is that let's test things out, Kalyani, because you enjoyed the visuals of this and building some very pretty graphs. I thoroughly agree. What if we could just turn problems like this into numbers? So NIST has a proposal about likely exploited vulnerabilities, a way to have a metric for vulnerability exploitation probability. Now, they're basically trying to bring together the idea that there's a ton of these CVEs out there. They've got CVSS scores. Everybody likes to pick on CVSS. EPSS came out, tried to have a little bit more of prediction about, will this vulnerability be exploited within the next 30 days, for example. And CISA, of course, has been posting the KEV, the known exploited vulnerabilities, which is kind of an after the fact warning saying, hey, we know this exploit or this vulnerability has been exploited. Should probably bubble up the importance of this. But now we've got some other stuff, and as I'm using technical terms, from NIST. So there's no helpful visualizations in here, but there are some numbers. What do you hope to see out of some of the numbers from NIST here, Kalyani?
So I feel like I've said this a bunch of time, and maybe people will get bored the more I say this, but I hate following a prescriptive approach to security, like the whole
Oh,
dump and run approach with like a spreadsheet full of like 400 CVEs. You take that and you dump it on the developer team and you say, go fix it. It's not helping anyone. They're not going to fix it. I will tell you today itself, they're not going to fix it. So I like that we are moving to like the math nerd in me likes that this is becoming more probability based triage score. And it is kind of enticing. I'm definitely here for that. But one thing I'll definitely add on to this is that human context will still matter no matter what the score says. The score can act as something like a decision fuel, but not something that will help you prioritize findings. For example, if we had something, like the previous article where we were like, there's admin access granted to every user, would you fix that first, or would you fix something that says the score is, I don't know, 0.93? It's all about the high impact, low effort findings at the end of the day. And I'm hopeful that NIST can help me with the probability math. And I won't have to burn my mind doing the math.
fair. And part of it too is I like that approach as well, because for me, all these CVEs just represent unplanned work. And if you're going to throw unplanned work onto a dev team, make that unplanned work useful rather than, like you said, just do this because I said so, which is the worst scenario you can come up with. A slightly second worst scenario is just do this because it has a CVE associated with it. Okay, that's fine. It's a known vulnerability, but really, is this like regex DOS something we really care about compared to root in our AWS, or what our MCP agent is doing? And there's a lot of really, honestly, junk CVEs out there. And I say junk in the sense of they still impact software quality. They're bugs. They're bugs that should be fixed, but they don't need to be prioritized. And even in the intro to this study, or this article from NIST, is that they were pointing out a study that said only 5% of vulnerabilities were observed to be exploited in the wild. So if you're giving all of your developers 100 vulns and 5 of them were only the ones that had any potential risk associated with it, you just wasted a bunch of time. And this is where I also think I'm going to pull everything back to LLMs. I've heard proposals about LLMs as they can fix things, or they just give this kind of tedious work to LLMs. I can understand the sentiment or the desire there in the sense of, hey, save me some time or save the developers some time. But I don't know if you actually are saving them any time if they have to confirm what the fix was, that the fix didn't actually change behaviors in the application, and that the fix, for example, the LLM, didn't change a test case to make the test case pass so that a bad fix fixed the security bug but broke something else. So there's a lot of, we'll call it trust or just reliability of that code that I have to admit I'm still skeptical on. So anything that can help developers or help AppSec folks filter down, these are the phones I care about. These are the few CVEs. Let's fix them and then move on to something else more interesting and deliver some value. That's going to be music to my ears. For our listeners, I've got Kalyani at least apparently convinced because she's nodding her head, and I don't know if there's anything else to add here, Kalyani. We've gone through a bunch of the news articles that crossed my path for the last week. Any final words or anything else you'd like to send our listeners off with here?
I think I want to leave the conversation with a question though. I
Oh,
feel like
good.
we do have a lot of threat models, and we're always talking about like, let's improve the model, let's fine tune the model, let's sanitize input. But if we saw a bunch of articles today, the trend today was there's a trust leakage soup going on here, and most of it is because of context window being an untrusted space. And so I wonder if there are ways in which we could just threat model the context window, or maybe I'm making a futuristic ask here, but yeah. Or if there's anyone who's doing that out there, a vendor, I'd be very happy to talk to them.
Well, so that's interesting because, and I'm going to sort of torture a metaphor or that parallel with cross-site scripting in the sense of, with cross-site scripting, we would want a more reliable defense of output encoding. What's the context? And I'm using the word in a slightly different meaning than the AI and LLMs context window. But with cross-site scripting, what's the context of where we're planting this arbitrary text from a user that we don't necessarily trust into a DOM? And this is where we know this should be encoded in this particular way so it's safe. It's now inoculated because it doesn't have quotes in it, or it's not going to create a new DOM element. It's just going to be treated as plain text, and that's a good thing. It's interesting to where do we apply these controls, as you were conjecturing? Should it be within the LLM context window and within the LLM itself? Or do we need the supervisor LLMs, as I've seen other architectures be proposed? Or do we just have more binary inputs, outputs? Because we don't, in the sense of an LLM can decide something, but it's hard to restrict where it's pulling in that cross-site scripting or that prompt injection payload from. And I think that's what's the interesting challenge that points to the defenses need to come somewhere from outside of the LLM itself, because it's so non-deterministic, so unpredictable that we haven't seen strict boundaries, which is what you want from a security. So that's going to be my thinking. And as you can tell, listeners, Kalyani and I are both trying to think through this out loud. And so we're sharing our ideas with you. Please send us an email. Let us know what are some other things we could be reading or thinking about in this area to try and share some good architecture. So with that, I want to say thank you very much once again to Kalyani. Thank everyone for joining us. Please do remember to subscribe, especially if you're a human. Check out the show notes, share us on the socials, and speaking of things that just come and go, check out Sandwaves by Caspro. We'll see you next time on Application Security Weekly.